I made it easy on myself with lecture by making it automatically record as soon as I start the meeting, but this one's not that way. Okay. Yeah, so we got a few more people coming in. Thank you all for joining me on this what's turning out to actually be, it looks like a pretty nice Saturday morning. It was storming all night where I am.
That wind was crazy. Oh my gosh.
Yeah, it really was. Okay. All right. Thank you for continuing to monitor the waiting room, Devin. I think I'm going to go ahead and get started. Okay, so welcome to our first Saturday live tutorial that's kind of off the books. I created this prep exercise about backpacks, gosh, 2.5 years ago, I guess, for a group that I was TAing for with the Women Plus program. And it kind of was like, I remembered how much my class struggled with Mars Rover. We were the very first cohort that had Mars Rover. It was brand new. The JavaScript unit was brand new. They had been teaching Python before that. And so we were kind of the guinea pigs, and everyone really struggled hard with it. And so I thought, you know what, I'm going to come up with something that will kind of help bridge the gap and, you know, help everybody connect the dots, because there's so many big concepts that are being put together all at once. So I did this one, but a lot of things have changed. My understanding of JavaScript has changed. Certainly, I understand things better than I used to at the time, but Launch Code also started using a different syntax for unit testing. And so I realized my old videos and the starter code and stuff was pretty out of date. So I started to like just kind of go in and revise this. And I ended up like taking a chainsaw to it. So it's kind of quite different, but I hope that's a good thing, because I think it's going to be relevant and hopefully a little more streamlined for all of you. So without further ado, I will share my screen. All right. So I've got up here, nothing fancy, just a couple of REPLs. I don't have any fancy slides or anything like I do for lecture. But I do have instructions in README files. So let's just take a look at this. This is part one. I have a different file for part two. There's a reason for that, but we're doing it all in one session today. So this is the backpacks part one. The point of this exercise is really just to talk about manipulating complex objects, creating them, manipulating them, because you guys have only had so much experience with stuff that's really nested inside of other objects and working with that. So I want to make sure you have a foundation of that before we jump in with classes and TDD and all that. So we'll just kind of go through this. It won't take too long, but the idea here is that you're going to create a backpack object that has 3 compartments. You'll have the main compartment, the front pocket, and the side pocket. And each item has its own object that has 2 properties, a name and a location. And the name has to be there. It's a string. The location can be a string, or it can just be null because you haven't decided where you're going to put it in the backpack yet. So I've got to-dos written in the file to actually kind of guide us through and give more specific instructions step by step. But when you are done, you should have created an object that looks like this. So you can kind of see there's main, front, and side. And inside that, here's those objects that I talked about, the item objects that have a name and a location. So we're going to do this step by step. And hopefully it'll kind of get you more comfortable with working with more complex objects. So I've started us off here with a backpack that is just an empty object. And So the first thing to do is to set those compartments inside of it. And so we can actually create the those with quick dot notation, right? And it just says, it should be empty for now. And so if they're going to be arrays that hold, multiple objects of their own, then we'll just initialize them to empty arrays. So I'll do backpack.main equals an empty array, backpack.front equals an empty array, and backpack.side equals an empty array. And just like that, we have 3 compartments in our backpack. So the next instruction is to run the program to take a look at it. And I've got a console log already down here, so we'll be able to see what the object currently looks like. And you can see that it is just an object with those 3 properties, and each of those is equal to an empty array. So far, so good, right? So let's take it to the next step. We're going to create a bunch of items with the 2 things we talked about. They should each have a name and a location. So we'll create a textbook. So I'm going to say let textbook equal, and then I'll create this object, and I'm just going to code it directly and say name is textbook and location. And we're going to put this one in the main compartment according to the instructions. Okay. And then I'll do the same thing here for pen. And put it in the front pocket. All right. And I can do the same for water. And I'll put that, and I think I want to call it water bottle. And we'll put that in the side pocket. And then it says we do an iPhone. And that needs to go in the front pocket. And okay, we're going to create a notebook. And in this case, we're not going to decide on the location just yet. So we'll just give it a location that says null for now, just as a placeholder for that property. That's where null is super useful most of the time. And then we have pencil, and we can do this real fast. Location front, which needs to be a string. Okay, and you may have already picked up on this, but I'll point it out now. It's going to be really useful in a minute. The strings that I am, using for the location on each of these, they correspond exactly to the property, the keys of the backpack properties, right? And if you remember, keys are actually technically stored as strings, even though we don't, type them that way when we're creating the objects like this. They are actually stored as strings. So that's useful because you can use those with bracket notation and actually use them as keys. So that's going to be immediately helpful. So we are going to write a function that's going to add a single item. We're just concerned with one item to the correct location of the backpack. And if the location is unknown, we'll set it to be in the main compartment by default. So there's really kind of 2 things going on there, right? Because one is, pushing them into those arrays, whichever the correct array is that's in, this object up here. But then, of course, if it's unknown, it says set it to be in the main compartment, which means we also need to change the value of this to say that it's supposed to be in main. And if we do that first, then we can just kind of use the location no matter what it is after that. So let's start by just setting up our function. We're going to have a function called add item, and it's going to take an item that is one of those objects. And yeah, let's go ahead and handle the null case first. So we'll say if item.location, oh, actually, we could say equals null or is null. We also can just use that bang operator, right? Because that basically just says if it doesn't exist or if it's undefined, if it's null, if it's falsy, and null is falsy. So that'll take care of it. So if there is no item location, then we are going to set it instead to main. Yeah, that's what we instruction said right here to do. So that takes care of that. And now that we are at the point where we know when we get to this point in the code, every item should have one of those three values, main, front, or side, right? So now we can actually just put it into the arrays. So here's the question, like the first line of thinking, I think for most of us is, okay, so I need like if and if else and else, right? I need like some logic to set up. And we could definitely do it that way. So I'll code that first. So we could say like, you know, if item dot location equals main, and having trouble with a couple of my keys that are a little sticky today. Then we would say, you know, backpack dot main, and then we'll, you know, that accesses that array, and then we'll push item into it, right? And we could kind of repeat this and say else if, and then we could go through and, you know, if it's the front, then we'll push it into the front. If it's, you know, otherwise it must be the side, so we'll push it into the side. But we actually don't need to do that because, as I pointed out a few minutes ago, these keys of backpack are main, front, and side, and the locations that, you know, these strings are main, front, and side. And while ordinarily we find ourselves using dot notation most of the time because it's a little easier to read and cleaner, we don't have to. So we could actually here just make this bracket notation, and instead of specifying which one, we will just say item dot location, and that way it'll give it that string, you know, side, front, or main, and just choose the right location in the backpack, you know, whichever one of the three compartments, and push it into the right one. So this is a, you know, a really streamlined way to take care of it in a single line. And then it doesn't matter which one it was. We're just taking advantage of having set things up like that, which may or may not have been on purpose. It was on purpose. But that's experience, right? On my part. Okay, so we've written this add item function. So the next thing to do is to kind of create an array that holds all the items. And I'm just going to call it items. It's, you know, keep it simple, right? For our purposes, we don't need to be more specific than that. And I've named all of these objects, so I'm just going to use them real quick and just put them in like this. And this is kind of the fastest way to come up with dummy data. But this really does kind of simulate the way that a lot of data comes in when you get it from databases through an API in the real world. So it often comes where you just have a bunch of objects that all have the same properties, and they come in an array, or maybe in an array that's a property of an object. But anyway, you usually have like one big array full of data to work with identical structures. And so then you can work with them like this, and it makes it a lot easier to manage. So we've got that. So let's go down to our next to do. Okay, use a loop to put each item into the backpack using the function you wrote. After each is added, use a template literal to print the name was added to the location of the backpack. Yeah, we definitely don't want to have to do that 6 times. And we want to make, you know, this flexible, so we'll use a loop. So this is an array we're talking about, so I'm just going to use a classic for loop. And we'll just say, you know, less than items dot length, because we're just doing this just for items. And we are going to call our function, add item, and we're going to pass in whichever item we're currently on. So we'll take items at index I, and that should add it. But it says we also need to print something, right? So we'll print a template literal here that says the name, and we need a placeholder for that, a proper JavaScript placeholder, not parentheses like I wrote. Okay, so we need, so how would I do this? Somebody tell me how I would reference this to get to the name from where I am right now. And y'all don't have to raise your hands. You can just like shut it out. That's fine. Anybody?
Item.name.
Close. We don't have a variable called item available to us in this loop. What do we have instead?
Well, we have the iterator, so we should be using items bracket notation iterator
Exactly.
dot name.
Yes, perfect. Yeah, so that's the way to do it. You work with what you have and you reference things based on, you know, what you have. So in this case, I had the whole array name and I had an index. So that represents the whole item. And then from there, I can access its property. So that's exactly right. Okay, was added to the, and we're going to do it again. Items at index I, sort of, dot location of the backpack. And I actually just realized that because, yeah, I need to put like the word compartment or something in here, or it's not going to come out right. Compartment. Put that in there. Compartments. Okay, and that should do it. So we're going to add the item and then we're going to say that we did it. So let's run this and see what we get. Yeah, the textbook was added to the main compartment. The pen was added to the front compartment. Okay, so we have, you know, our loop clearly was successful. We went through and we did it all. And now we can take, you know, a good look at our handiwork, and we ended up with the object we were going for, right? In each compartment, we have the correct object based on the location it said that it was supposed to go in. Or in the case of the notebook, the one that we put it in because it didn't have a location initially, it only had, you know, this null value. So we could stop here. There's one more thing I want to do though, before we move on. Let's also, we're going to loop through the backpack and print just the compartments. So somebody tell me real quick how we would do that. Don't be shy.
Wouldn't you use a for loop?
Yes, because in this case, the backpack is an object, right? And it has properties we can loop through. So, and those represent the compartments. So I'll do, you know, let compartment key, just to remember that that represents the key and not the value of, not of, in. There is actually a for of loop, but that's not what we're doing right now. In backpack. And then we will just say, you know, console log to keep it simple for now. And this is where we need the value. So we're going to say backpack, and then we're going to use that bracket notation again that we can use with variables and pass in the compartment key. So no matter which one it is, if it's main, if it's front, if it's side, it will print because we have this variable we've created that represents it. So let's do it. Yeah, a little hard to see after, like, so ignore that. We're looking at this. And now you can see that they've been printed individually. And if we wanted to go a step further, and instead of logging that and saying, you know, we want to, you know, print each item in each compartment, we could, you know, do a nested loop, right? And we could have a loop that looks a little bit like this. Except for I need to indent it again because of IDE craziness. Okay. Except for it wouldn't be items anymore, right? It would be backpack compartment key dot length, because this actually represents the value. It represents the array that we're currently looking at, as we just established when we were printing it. And then we would say, you know, console log And actually probably in this kind of case, when it gets super long like this, what I like to do, and if I'm going to use it more than once, I will put it into, or rather I would say, let compartment equal. And then it gets a little bit less, cumbersome. So then I can say compartment at index I to print the item object. Oh, goodness. All right. And yeah, and now we have all the individual objects one after the other. And if I wanted to go a step further from that and say, I want to actually, print some sort of little sentence, kind of like we did when we were looping through up here, I could do something very similar to this and, console log it and then just refer to the name and location properties of each of these objects. But I'm not going to, because we don't need to. We just basically did it up here. But anyway, yeah. So, becoming comfortable with how to reference things when they are like nested inside of objects. You have, objects that are inside arrays that are inside objects. And it can take a minute to get your head around it when you're not used to it, when you're first learning it. So I wanted to spend just a few minutes kind of going over that, because we are about to dive into something else in a big way that hopefully now you're feeling a little oriented with the objects, and we can focus instead on the classes and the methods we're going to be writing, sorting out some of the algorithms, and of course the test-driven development and writing all the unit tests. So that brings us to part 2. So this one is set up like several of the things you've worked on, where the Jasmine stuff is in the index file, so you can just run it, and right now it's going to say that there are 16 specs and 0 failures, because I actually have like the tests as placeholders in there, but they don't have anything inside them. So Jasmine will still run them and they'll tell you, oh, they all passed, but there's no content in them. There's no expectations. So like, it doesn't mean anything, right? So we're going to continue to see that unless I was to go through and comment them all out. Ordinarily, when you do this, obviously you would be starting at 0 and working your way up. And so you'd see, 1 test passing, 2 tests passing. But yeah, so let's work on this. Let's start with the README because it's backpacks, but it's a little next level because of the classes. So you're a little familiar with kind of how this works, right? The backpack with the main compartment in the front and the side pockets and stuff. You're actually going to be defining classes that represent these. So we will be working on that. We'll have an item class, a compartment class, and a backpack class. And we'll do them from the smallest object outward, because we're going to do this thing called class composition, where one class is actually going to be made up of objects from another class. That's different from inheritance, right? Because inheritance is the concept of having a class that has properties that you also want in another class, but you need something slightly different. So you just, basically pass them all down. That's not what composition is at all. So you're going to kind of see what composition looks like as we work through this. We are going to be practicing TDD. So we will, read the instruction in the class file to understand what the expected behavior is supposed to be. But then we'll go over to the test file, write the test, watch it fail because the code doesn't exist yet. And then we'll come back and we'll code it so that the test passes, hopefully, and keep working on it until we get it right. And then the test should pass. And then we move on to the next one. We'll do that 16 times. So then it's broken down like so, and these numbers are wrong because I did not update them. So ignore what it says about 1 through 5 is correct. I don't think 6 through 8 and 8 through whatever are right. I'll fix that later in the notes. But yes, the first ones, several tests are just to do with items. So we're going to start there. And you're already familiar with this, that it has a name and a location, and that we can use these as keys. So we will, get into that. And then after we're done with those, we'll go to the compartment. And the difference here from what we were just doing in the part 1 exercise is that the compartment has a property of its own that is what called items. That's what holds that array. So there's kind of an extra reference that's going to be there because of that. But it's a good example of kind of how to do composition. So we're going to do it this way. And then of course you've got the backpack that has the 3 compartments. So that will literally be made up of, it's composed of 3 component objects, component class objects. So yeah, I'm going to kind of show you like how to check that an obstance is an instance of a class. And there's this other thing, this thing that I've got some notes on here that basically just says that with Jasmine's current syntax, like one of the things that I talked about in lecture when I was talking about Jasmine is that you could use to equal for both shallow and deep equality. Remember that? So like if you're comparing 2 objects or 2 arrays, it actually compares the things inside of them and doesn't worry about like whether they're actually 2 different things in memory. That's great for regular objects. It does not work for objects that were instantiated from classes. And I actually came across this thing in like Jasmine's GitHub, forum for like people raising issues that need to be worked on so that they can, bugs or whatever. Somebody brought this issue up and said, hey, can't you guys come up with a matcher that will allow us to check class equality without running into this issue? And they kind of talked about it and they were like, nope. So what that means is you have to use your references to get down to the data that is inside of the class-based objects so that you can compare that data instead of trying to compare the whole object if it's class-based, because it just won't work. So all the examples we'll be doing will be, working very carefully around that issue, and I'll show you how to do it. Okay. Let's hit it. We're going to go into item. And of course, we have our corresponding test file. I'm going to move this over a little bit. Test file here, item.spec. So let's look first at kind of where we are, just what we're getting ourselves into. So I've got this class item that's kind of structured out here a little bit, but there's obviously lots to do. So our very first task is to add a name parameter and set the name property with it for the class. So let's go write the test for that, and then we'll come back. All right. So this one, I've kind of written this one out in steps just because it's the very first one, to kind of talk a little bit about how you think through writing a test. Because when you're just looking at a blank test, it can be a little scary. You're like, wait, what do I do first, right? So the first thing we're doing, and just to revisit this syntax, I'm testing the item class in this file. So the describe block just says the item class, and then the sentence continues from there for each one on what it is about the item class specifically that I am trying to test. So this specification says it correctly instantiates an object when the name is passed in as an argument. So all we're just trying to do is make sure it works right if we have a name parameter and a name property. So we will first set up a test item of the item class. So, we learned just a couple days ago how to do this, right? We can say, I'm just going to call this, let's use real names. I think it'll be helpful. So let's call it textbook. And I'm going to say it's a new item. And I know that I'm going to create this name property that's going to be my first thing. So I'm just going to say, I'm giving it the name textbook. And that's it, because that's all we're gonna do on this test. We're not going to worry about the location at all. That's we're doing one thing at a time. So we will establish that test item. So we've got something to work with now. And then the next step is to write the expectation that verifies that the item is an instance of the item class if it correctly set it up. So we can do that. We can say expect and then textbook, and then use this matcher, is no, to be instance of, there we go. Got to get the right prepositions in there. And then we can just name the class, which we have already imported up here, right? So it's available. We were able to create an item out of that class, and now we can actually check and see if it's this object that we've instantiated is an instance of item. So that's the first part. And then the second part is to write the expectation that actually compares the name property. And this is where, you start doing simple references. We're starting off easy. So if I want to test the name property, what do I put in the expect as the parameter for expect right here?
Name or like item.
Well, what name specifically am I trying to test? It needs to be attached to a specific object, right?
The textbook or the backpack, I'm guessing.
Well, there are no backpacks yet. We're just working on the item class. So yeah, it's just going to be the textbook. That's what we want to test. We want to test the name. So we've created a textbook. Sorry. Wow. I can't seem to get that out. We've created a textbook from the item class, and we are expecting it's going to be an instance of item, and we expect that its name, to equal. And then we can, literally check it against the text that we're expecting to see. Because if this item has correctly been, once we create the code for it, if this item has correctly been done with a name property, it should set it properly if we do it right. And then we'll expect that we can access that property and see that it did get set properly as this value. So you always start with the reference to your actual code, and then you have some sort of value that is what you expect to be returned from that expression. And that's what you're comparing. So we've got this, we can run it, it's going to fail because it's saying it's undefined, right? Textbook.name is undefined because we can't right now successfully create this item because we haven't set it up yet. But this is the way test-driven development works. Remember, it's that red-green refactor. So this is the red part where you fail on purpose. Now we come back over to item and we work on this, right? So it says add a name parameter. So we've got that. And then it says set the name property with it. So if you recall, inside a constructor, we set properties with the this keyword. And then we're just going to say whatever is passed in through that constructor as a parameter, that's what we want to set the property to. So name gets passed in, and then we use it to set this property. So this is exactly why we expect this test is now going to pass, because we've just said we're going to construct it this way, and then we're going to set that value that way. So let's run it, and it passed. All right, does anybody have any questions about that first test before we move on?
I have a question. So instead of like the two equal, can we like define like a 2B or like, because like I was trying a lot of things in Jasmine's like a 2B to be, so we can use anything, right?
You can use to be, one of the things that I had talked about in lecture about to be is that it is strictly shallow equality. So you can only use it for primitives like a string. So yes, it would work here. And if you want to mix it up and use to be part of the time and to equal other times when you can't use it, can't use to be, that's fine. I personally find it easier just to remember that to equal works for both. And so why not just use to equal all of the time, right?
Okay,
yeah.
Because like I want to try something different, so I tried it.
Yeah, absolutely. It's good. Oh, I screwed that up. Wow. It got away from me. Yeah, we can run this right now. And because this is just a string, it's going to pass. But if it was an array, if you're trying to compare like two arrays, it wouldn't work. So to equal will work both ways. The only thing it doesn't work for, as I mentioned earlier, is for objects that are based on classes. But yeah, so we're going to actually use a lot of different matchers during this. I mean, we've already used one, right? To be instance of that wasn't one that was in your textbook. Okay, so our next thing is, what happens if a name is not passed in? And so, the idea there is that, we need to throw some kind of error because the name has to be there or the object isn't going to get created properly. So we can actually, come back over to this and look, it says, throw an error if no name is provided at instantiation. So we'll write the test and then we'll put the code in to do that. And this is one of the things that I didn't have time to do in lecture that I wanted to make sure to do today, is to talk about how to write tests for constructors of classes. Because when you first learned unit testing, we hadn't talked about classes yet, right? So this is a helpful one. You can essentially say that there's a like to throw error. There's to throw and there's to throw error. I like to throw error because it's really straightforward. You can just give it the message and it'll just compare the string. So we are going to do it that way, use that particular matcher. But here's the kicker. You can't just create an item and try to compare the item because the item is an object. What you're trying to compare is the action of instantiation, the function of the constructor itself. So in order to actually capture, is the constructor correctly working or not, or does an error occur? You have to put it inside an anonymous function. So what you do instead, and I'm going to use this crazy variable name that's going to help us remember what we're doing. I'm going to call it instantiation attempt, because that really is literally what this represents. And it's going to be an anonymous function. And here is where we just say, I just want to try to create a new item. And I don't want to pass anything in because that's the whole point. We're trying to see what happens if we pass, if we try to create a new item and we don't have a name in there, because we're saying that names have to be, they're required, they have to be there. And so then what we would also have then is we want to establish what the error message is that we would expect to see. And I really should put a let on the front of that. Feel like I've got oh, I guess it's just because I haven't finished this yet. Yeah, okay. It's just giving me red squiggly lines, and it's just because I'm in the middle of typing. Okay, and we'll just, say, name of item is required. Some sort of error message is probably what we'll use when we code it. And so then the expectation is that the instantiation attempt, I was hoping it would give it to me, but it didn't. We expect this to throw error, and it'll be that error message. So this is the syntax with to throw error. And again, just to be clear, we're expecting the action of trying to create a new item to throw the error. That's why we have to wrap it in an anonymous function, because we're capturing that process of doing it, of attempting to do it. Because what's going to happen is if it throws the error, it doesn't create the object. So we don't have an object at all. So we can run this and it's going to fail because we haven't thrown an error. So let's go do that. Now that we know what we want to do, and I'm going to copy the string for the message so that I can get it exactly right. This is the great thing about working backwards. Okay, so remember that constructor is just a special function, right? So this is just lines of code. So yeah, you're setting properties, but you can do other stuff in here too. And so we can actually just put a line right in here that says, if there's no name, throw an error. And we'll give it drat. There we go. We'll give it that string that we already decided we wanted to use and put in our test. And that should be it. It should just say, if a name wasn't passed in, throw this error and spit this out. So let's run it now. And it passed. Okay, so we did that right. Does anybody have any questions about this?
Carrie, sorry.
That's okay. Go ahead.
I might have missed this, but why can't we just put the string in? Like, why did we set the variable as error message?
Because sometimes they get really long.
Okay.
This is a short error message. I mean, but even if it wasn't, the line starts to get a little long.
Okay, so it's just for like.
Yeah,
keeping it
in places
clear.
that I've worked, like, there's, you just try to keep it like to 100 characters or less, basically. And so if you have something long, you're typically going to put it on another line. But yeah, it's totally up to you. You can put it all in one line if you want to. I mean, I could have put this entire anonymous function right here in place of this and not given it a variable, but I think it's easier to read like this, especially for you guys looking at it for the first time, right? So yeah, it's a choice that you make. And I wanted to spell it out a little more clearly for you. Okay, so the next test says, what happens if a valid location is passed in? So we're talking about the second property, location. We want to make sure that our class can correctly instantiate an object when a valid location is passed in an argument. So this is going to be kind of similar to what we did with the name. So let's just double check the instructions over here. Yeah, it just says add a location parameter and set a location property with it, same as name. So let's come back and do this then. So first order of business is we're going to need an object to work with. So we're going to let's say this time we do a pen, right? New item, pen. And we first expect that the pen is going to be an instance of the class. We want to make sure of that. And then we want to actually check the property, the location property, to make sure it got set properly. Because they're two different things. So we can just say pen dot location to equal, and I put in no location, so that doesn't help us, does it? Okay, so we would say we want to put this in the front pocket. It helps if I set the test up right. Okay, yeah, so we're going to look for that location property for that second parameter that we have not created yet, and expect it to be equal to that string. So yeah, it's undefined as we expect it to be because we haven't written it yet. So now we'll come in here and we'll follow number 3, add a location parameter and set the property. So we're only adding as much code as we need every time we come back and do this to satisfy the test we've just written. And we want to do this in little increments. This is the way to catch your mistakes as you go along and not end up with a big headache because you wrote, 50 lines of code and don't know where you got it wrong. Which from personal experience, I can tell you is frustrating. Okay. So now if we run it, having, given it a parameter and then used that parameter to set this property, it should pass, and it does. Okay, so we're going to do something similar here. What if the location is invalid? But this is a little different because, and we need to go back to this. It says throw an error if the location is provided, but it's invalid. Because we know that the location needs to be one of 3 very specific things, right? It needs to be main, front, or side. So we can actually write a method right here that will help us determine this. And we could just call it something like, is valid location. And we don't need to pass anything in because we're inside our item. We can access any of the properties we want from inside here, right? So we're just gonna make it simple like that. And we could, for the sake of simplicity, again, I'll put this in a variable, just keep it on a separate line. But we could say our valid locations are main, front, and side. These are what are available to us, and we need to make sure that we actually are matching that. So we're going to use the includes method to just check the location. And if we call this, it'll run it and it'll look and it'll check. And so we're going to call it in the constructor. And the thing about this is that the constructor only runs once. It runs when you instantiate, it does not run again. So this is only going to happen at this very first thing, but that's what we're testing for. We were testing that when you create something, an item for the first time, that the location is valid. So that's all we need to do. So now we can do something kind of similar to what we did here and say, if there is a location and if not is valid location, right? And we have to make sure to say if there is a location, because on number 5, and I realize I'm kind of doing these out of order now, but on number 5, so I could just do it like this, because this is the whole point of refactoring on each thing. We'll just say if it's not a valid location, because that's all we're worried about right now. Then we want to throw another error. And I'm totally coding this, and I didn't write the test today. You guys didn't stop me. Okay, it's not your fault, it's my fault. But we should actually write the test first since we're practicing TDD. Okay, so let's set this up. I'm actually going to just copy what I did in the second test because it's so similar. The difference being that this time we want to have like you know, a real item. So say it's a pen, we want to give it a location that's bogus, right? So we could say, you know, New York, which is, I realize silly, but it'll do the job. So let's say that we are trying to do that. It's not going to match. And so our error message should probably be something like, you know, valid location is required. Okay, so I'm going to copy that. And now I have the message I know I want to use. And so now, you know, this still works, right? Because we've updated this and we've updated the error message. So this line is good. That's another reason I do it sometimes, is to make it easy to copy. Okay, so we'll go back here and we'll finish this. We're halfway through. Damn it. Okay. Quotes, there we go. All right, so now we have written this little method to go and check and make sure it's one of these 3. And if it's not, it'll throw this error, we hope. Let's run it. Oh, it's not defined, huh? Yeah. Does anybody see what I did wrong? Can I take a guess? It's a very easy thing to do when you're working with methods inside a class. It can't find it. It's clearly right here, right? And I've even called it. I've got the little parentheses on the end and everything. What I forgot is that I'm inside a class, so I have to use the this keyword and actually call it on itself. So if you get this and you're like, but it's right there, and it looks like my syntax is right. Yeah, check if you've got that this keyword, because that's probably it. So let's run it again. Okay, now it's giving me the error because something else is wrong. So my messages are correct. So let's go back and look at, let's see, if not, this is valid location. Valid locations includes this location. Okay, so I think that's right. So I might have made a mistake with my test. And this happens too, right? You're writing tests and sometimes it's the test that's actually wrong. So you just have to double check everything. Okay, let instantiation attempt, new item, pen, New York. I might have to console log some things. So this is how we debug. Let me come up back to my code here. And I'm going to do 2 things.
Is that exclamation point in the right place on 19 in front of this? I was just wondering.
Yeah, because basically that's just saying if like this is going to return true if it is valid, right? And so we only want to throw this error if it's not valid. So we want to negate it with that bang. yeah, so I'm just gonna console log this dot location, make sure that it's actually there, and then I'm also going to console log actually, yeah. Oh, goodness. Okay. In the if block, just so I know where this console log came from. In the if block front, oh, it's because it's doing it for the other one I ran to. New York in the if block. That's interesting. It's now, see, I didn't read my own test. Okay, do you guys see what it is now? It's not that I did anything wrong with this test. It's the previous test it's failing. And that makes sense because I'm gonna take these console logs out of here. It makes sense because this very first test, I'm actually, instantiating without a location. And so this is why I probably should have reversed 4 and 5 and done 4 first. So, done 5 first, because this will all be fixed when we allow location to actually default to null. So let's go ahead and do that. And I'll reverse these for the starter code later. Okay. Sorry, guys. I do my best to think these things through as thoroughly as possible ahead of time, but sometimes I don't account for everything. All right, I'm gonna just move this down below the other one. I'm gonna reorder them. I'll fix the numbering in the other file later, but I'm gonna actually just completely take this out. And now but the code is still there. So hold please. Okay. Yeah, let's pretend we haven't done that yet. Okay, so everything's cool. So let's take care of this one. Actually, we'll call this one 4 and this one 5. Because that actually does matter. It's going to mess up our other test if we don't take care of this first. Okay, so we need to basically make sure that we're handling that it's okay for this to be null. So let's go back to the test. We'll write the test for this. It correctly instantiates the object from the class with a null location when the second argument is omitted. So we want it to work and not break for this. So if we let, I don't know, eraser equal new item, and and we just give it eraser without giving it a location, we would expect it to be an instance of, and then we would expect the location to be null. So I'm going to start with this and just say eraser as an instance of item, and then eraser location. And here's where to equal, I could put, to equal null here, but why don't we mix it up and use, to be null instead? Because I can, and actually that needs parentheses. So there we go. All right, and it should fail, but we are going to go fix that. So we will come in here and just set it here, right? That way you can pass in a valid location, but you can also leave it off, and now this becomes an optional parameter. So now if we put back our code that's going to throw an error, it shouldn't throw errors anymore when the first test runs, because we are allowing for this now. Let's come back here and we will put this test back and run it. And we still have a mistake. Okay, correctly when the second argument is omitted. Oh, right, because remember I said that I was leaving off part of the logic here on purpose. Yeah, so this is exactly why you running everything every single time to make sure that you haven't broken one thing because of something a change you made for a different reason. And this is a perfect example of that. So everything looked, rosy and wonderful, but we also realize now if we're going to allow location to be null, then we can't just say, check and see if this is valid. We have to also make sure that there is a location before we do that. So by using the and operator, it first looks at this and says, is there actually a location? And if there is, then it'll continue with this logic and look for this before it goes into here and executes this code. So if there's no location, if it's null, then it won't even execute this. And so there's no problem. Yeah, and now it passes. Is that clear? Anybody got questions about that?
Can I ask a question about the testing? Is it just best practice to include that it has to be an instance of item? Like, why would you need that as long as you have let eraser equal new item, Like, is that just to cover all your bases?
It's yes, because when you're testing a constructor, really. Like when we move on to backpack, we're going to have a couple of methods that we're writing. And we don't need to do that for, checking the methods or anything. But for the constructor, it's generally a good idea to just make sure that the object is actually an instance of the class in the first place before you go checking the particulars of it. It's just, yeah, covering your bases. I think that's a good way to say it. Because they really are two different things. It could have, created the object without it. I mean, you're right. If you get here and this passes, then this clearly also has to be true. But it's sometimes some people would probably, possibly split this into two separate tests because they just want to test this on its own. You can get very granular with how specific you decide to be with your specifications. In this case, I just decided to combine the two into one test, so it didn't get too crazy. All right, so yeah, so we've done all 5 tests. We're good with the item class. So we feel confident now that our items can be created the way that we need them to be. They're going to take in the values and set the properties correctly. So we're going to be able to use our items now for some of these other classes. So now we will move over to compartment. And oh, I see. Yeah, I have imported item at the top because we need it for some things. But basically we're going to, just have an items parameter and set an items property. And then we'll throw an error if any of the items in the array are not instances of the item class. So that gives us a way to just double check that we haven't put in something that wasn't even an item in the first place. And then we will make sure that we can handle a default value for it. So we'll do this one at a time. So let's come over to the test then and get started on that. All right, I have imported the item class so I can create items to put in the compartments. And I've imported the compartment class because that's the one we're testing. And we need to create those as well. All right, so let's start with the first one. And the tests are going to start getting longer. If you remember from lecture, I was talking about how Jasmine randomizes the test. So for your purposes, since you guys are learning this in short order, the best way to make sure your tests pass every single time, and it doesn't matter what order they're run in, is to set up brand new test data inside every single test. And I know that seems antithetical to what we tell you about writing dry code, but for testing, it can be a good practice if you're not going to use fancier ways of doing things, and we don't have time to teach you that because we have lots of new other exciting things to teach you. So we're just going to continue to set up brand new test data for every single specification, and probably I'll do a lot of copying and pasting. Speaking of which, there we go. We have a notebook and a binder now. They're both going to go in the main compartment. So I'm going to, here's what's new. I'm going to also create an object that's a compartment because I have 2 classes that I'm working with now. So I'm going to call it main because that's the one I'm going to test. And it doesn't matter what I call it, but for my purposes, it makes sense to just call it what it is. And we are instantiating a new compartment object. So what we're planning to do, according to the instructions we read, is to have this accept an array of items. So we can just go ahead and put these inside it, these 2 items that we created. And these are the objects, the full objects that we instantiated from the item class with these values for name and location. So those are now in an array. I am passing them into the constructor for compartment. And the plan is that we will have a items property that'll get set to that array. So let's write the expectations, and then we'll watch it fail, and then we'll go code it. So I'm first going to just check that it's an instance of the class. The class is actually creating objects the way it's supposed to. I wrote component. I'm going to keep doing that probably. Sorry. But then I'm also going to check specifically that the items, are also an instance of item, just for the sake of making sure they're going to do what we expect them to do. But you can choose to do this a lot of different ways. I mean, I could also just like check their name property or check, but we already know that the name and location properties get set properly because we just wrote all those tests, and those tests are solid. So we kind of don't have to worry about testing the properties anymore. We just want to make sure that we've set all this up correctly and that it actually is what we think it is. And that's because we're not testing against notebook and binder. We're testing it against main.items at index 0 and main.items at index 1. So what we're really testing is, did that item make it into that array, into that property, that main property, the way that we're hoping it did, if we have written our class correctly. So it'll fail. Can't read 0 of undefined because there is no array because it doesn't exist yet. So let's go code it. And I went to the wrong file. Compartment, here we go. Okay, so it says to add an items parameter. Check. And then give it a property, items, and set it equal to the value that comes in from that parameter. All right, so now if I run this, hopefully it should pass, and it does. Okay, so that's pretty straightforward. It's just a single property, and we just had to do a little more work now because we're starting to compose our classes of other classes, objects from other classes. So we have to kind of set some things up. But this is extremely relevant for how you're going to be doing Mars rover, this idea of composition. Okay, so the next one says, what happens when one or more items in the array that are passed in are not valid instances of the item class? So we can set this up, and this is going to be another one of those ones where it's a function that we're actually testing the process of instantiation. So we're going to have to set it up a little differently. So let's do that. Let instantiation attempt equal, and we'll do an anonymous function. And we'll just try to create, we don't even have to set it equal to anything. We're just going to try to create a new compartment. And instead of passing in item objects, I'm going to just kind of, give it whatever, regular JS object. So I'm not passing in something that's an instance of the item class. It's just a regular object that has, meaningless key and value pair here. And that's the point. So if I do that, we would expect then that we would have an error message. So let's get our message together. Whatever we want to write. All items must be valid instances of the item class. And then we can do our expectation and say that the instantiation attempt is going to throw the error message. And that should fail, of course, because it doesn't throw an error. So let's go write it so that it does. Okay, so throw an error if any of the items in the array are not instances of the item class. And it says, hint, write a method to help with this. So this will be kind of like we did for that, is location valid thing, right? So we can, kind of sketch out this logic here first and say, like, if invalid item or something like that, and then we'll throw the error. And I did not even copy it, much less put it in quotes. So let me go get that message I wrote. I'm in the right one. Here we go. All right, just want to make sure I get it right. Okay, so we want that specific sentence to be thrown per our test. And so now we need to come up with this, is invalid item, and it's going to be a methods. And I almost forgot the this keyword. So this is what we're going to call it. So we'll come down here and we'll code it. And I'm going to change the name of this to say has invalid item, because this is an array, right? We're actually looking at the entire thing. And we're doing this after we've saved it to the property. So we can just refer to this dot items so that we don't have to pass anything in. So we'll call it has invalid item. And then we will get to the testing, which is really as simple as just kind of looping through the items array and checking them one by one. So I'm going to set up a simple for loop. And I will be based on the length of this dot items, whatever was passed in and set in that property. And then we'll increment. Got my shift key turned around. All right. And on each one, we're just going to check. And if we actually find one, then we'll return true. Yes, it is invalid. It has an invalid item. And if not, at the very end, we'll return false if they all pass muster. Okay, so I need a whole expression here that I'm going to negate, which is this items at index I is an instance of item. And by the way, in class the other day, when I was trying to do the typo thing, I remembered the wrong one, and I actually meant to do instance of. So this is how you check to see if something is an instance of a class. You use instance of, not type of. And so we'll just check. And if the particular item we're looping through in this array is not an instance of item, if this comes back true, then we will return true. Yes, we have a problem. But if we get all the way through the for loop and it hasn't done that early return, then we just need to return false. And if this comes back false, of course, it won't throw an error. This will never execute. Okay, so let's run it and see if this works. It does. Okay, good. Let's move forward. Okay, so what happens when no arguments are passed in? And the reason we ask that, if we go back and read the instructions, is that the instructions want us to give the items parameter a default value of an empty array right here so that it's optional. And so in that case, we would expect, wrong file, we would expect that it should instantiate a new compartment object with an empty array as the value of the items property. So it's not going to throw an error. It's going to be allowed, and we'll be able to see that. So this is going to be really simple because we don't need to create any items if we're not going to pass any in. We can just create main as a new compartment. I mean, it doesn't have to be main, but sure, why not? And then we can do our expectations and just simply say you do expect main to be an instance of the class. It should create it correctly. And then if you want to go the step further of making sure that the value is what you think it's going to be, which is also important because you want to make sure the property gets set correctly. Then we check, main.items and say, is it equal to an empty array? And if it is, which it's not currently, because right now it's trying to read the property length of undefined, then we'll have a problem. But if we come over here and change this, let's say that it can be defaulting to an empty array, then we run it and it passes because it goes ahead and sets this for us, even if we don't use items at all. Okay, so that's it for this one. This one's very straightforward because it's just a single property, and that property is an array of objects that we've already defined and done tests for. So you can kind of see how unit testing, this is the power of unit testing. You can test things on a very small level, and the bigger you get in the way that you're putting all of your code together, the more confident you are because you've already taken care of the details of all of the little things. So we'll be able to focus on the bigger things as we kind of move outward. So we've done item, we've done compartment, now we can do backpack. So if we look at backpack, we've got a few things to do here. We're going to add the main, front, and side parameters. We'll do that all at once. We will throw an error if any of the three are not instances of the compartment class, because that's important. Just like we had to make sure that all of the items in the items array were actually instances of the items class. And then we'll set some default values so that we can actually, do it without passing anything in. And then we'll write some methods. We're going to go back and do that add item method that we did similarly in the first exercise. And then we're also going to write a method called fill that will take an array of objects and add them all at once, making use, of course, of this method up here. So that's the big picture. Let's go take them one at a time. Start with the test. Okay, so I'm describing the backpack class. We're starting big, and I'm concerned with the constructor rate. The constructor right now. So all these tests are just going to be, based directly on the class. So we're going to say, what happens when you pass in valid compartment objects for each of the three properties, and you expect that it should, correctly instantiate an object when instances of the compartment class are passed in. So we need to set it up, and here's where it starts getting long, because we have items, we have compartments, and now we have a backpack to create. I am going to actually do a little copying and pasting here so that this will go a little faster. So we've gotten as far here as actually creating the items that we want. I've got 3 items. I've created my compartments. We're familiar with how to do all this, and I made sure to pass in the arrays of whichever items belong in which compartments. I left this one empty. We just made it possible to do that, right, by giving that a default value. So now is the new part. I'm going to create a backpack. So I've got all of my classes imported up here because I need all of them to do this. So we'll just create a backpack. Keep it simple. Let backpack equal, use the new keyword, give it the name of the class, and then pass in something to the constructor. And we know that it's going to take those 3 parameters, right? Main, front, and side. So I've already created those, compartment objects. So I'm just going to pass them directly in. And you can see why, if I had not put these in separate variables, how long this line would be. Okay, so now I've created the backpack, so I can start doing some expectations. So I expect first that it's actually an instance of the class. And then I want to check that, do some spot checking on some of the items. So I'm going to drill down. This is where I really have to drill down. First, let's go to the name of the first item that's in the main compartment. So all these little pop-ups, my goodness. Okay, so we're going to start with the backpack, because everything needs to be referenced from the backpack, or else it kind of isn't, missing. It's missing the point of what we're checking, right? If we're testing the backpack, we start with the backpack on the references. I don't want to start with main. I don't want to start with textbook. I need to start with backpack. So we'll go to main, and then we'll go to the compartment property items, right? Because that's the property of the compartment class. And then that's an array. We know that's an array. So we'll go to the first item in the array. And then we know that is an object of the items class, and we can access the name property. Okay, did you follow that? Because that's a lot. That's a really deep dive. Just to walk it through again, we start with the backpack. We go into the main compartment. Main is one of the 3 properties we're about to create for backpack. Main is composed of the compartment object. So we've created these new compartment objects. And we know that from having just set that up, that it has an items property. And that items property is an array of item objects. So we go to the first index and we look at the first item, and then we access its name property. Okay, so now we have drilled all the way down from backpack down to the name of the very first object that's in the main compartment. And then we say, to equal textbook. So we have gone all the way from here down through here, and from here to here, and then to here, to that string right there, because we've got, the backpack is composed of compartments. The compartments are composed of items. So this is how we get there. And now we're going to do a couple more. I'll do another one that's similar. So I'm just going to copy it. We'll say from the front, we expect the name of that one, of course, to be pen, because that's the first item that we gave. It's the only item, I guess, that we gave to the front. And then what about side? We didn't give it any, right? We created an empty compartment. So in this case, a good way to do it would be just to check the items array directly. And you can actually, you can say, to equal, and then give it an empty array. I thought for a second about doing like, I don't know, like using the not keyword or something, but actually this is more straightforward, because this is exactly what we expect. We already know from the tests we did with compartment that if we don't give it anything, it's going to be an empty array. So this is exactly what we expect. So that's fine. We'll just do it like that. Okay, so let's run it and watch it fail. Yeah, it doesn't know how to find property items of undefined, because we haven't given it a way to create these yet. So let's go over and do it. Set this up. All right, number 9, add main, front, and side parameters, and set their properties with those values. So this dot main equals main. This dot front equals front, and this dot side equals side. All right, now let's run it. And it passes. So we have successfully instantiated a backpack object, and everything flowed through the way that it was supposed to. Main got the items in its compartment it was supposed to, and those items have the right properties. And so you can kind of see that the strength of a test I think this is a good example, and you're going to see lots more. The strength of the test, it's only as good as the test data you give it. So you have to understand the structure of your stuff well enough to set this up right. But once you do, then the next step is, how do I access the properties, drilling down all the way from the biggest item. And as long as you kind of have this, solid, everything works out fine. So I'm, spending a lot of time on this because it can be hard to get your head around it, but you guys are going to have to think about things a little more abstractly for Mars rover. So it's worth kind of spending, kind of the repetition of it will help you. Okay, so the next one says, what happens if you pass something in that's not a valid compartment instance? And this is where we're going to have to, write a little function to help us out. We can kind of go back over here and take a look. Yeah, it says throw an error if any of the three are not instances of the compartment class. And we can write a method for that. So really, we're just checking, that about the instance thing. And it only if we'll throw the error if even only one of them is not an instance. It doesn't matter if the other two are fine. So I'm going to test it that way, where a couple of them are good and a couple of them are not. So let me do this. All right, let's start with a pen that's going to go into the front compartment. And let's have this invalid compartment that is just a regular JavaScript object, has nothing to do with the compartment class whatsoever, which is exactly what we're trying to test. And then that is standing in for what should have been main. Front is going to be given the pen, and side is just going to have an empty array by default. And so then we want to set up one of those instantiation attempts scenarios so that we can make sure that we are testing the process of creation. And I'm passing in invalid compartment instead of main here on purpose. And then we can, excuse me, hold please. Just need a little water. Then we can, set an error message that'll probably be a little long. So I'm just going to copy it. Okay, so that's our error message. And then we'll do our classic, expect instantiation attempt to throw error. And then we give it the error message. All right, so we're going to run it. It's going to fail because expected the function to throw an error and we haven't told it to yet. All right, let's go do it. So we're going to have, some sort of logic here that's like, if and, writing a method for this is going to help. So let's say has invalid compartment. And I'm going to have to call that, and it's going to have to be tacked on to this. Right. And so if that's true, then we'll throw the error. And it's going to be that same message that I just had. Okay, so now to write, has invalid compartment and make sure we're covering all of our bases. All right. I'm going to check my notes to make sure I can think this through quickly. Okay, so I don't want to go too late. All right, so really, we just have to check each one, right? And only one of them has to be true. So that's a good place to use the OR operator. But because there's like these instance of expressions, I'm going to use parentheses to say it, not, and then do the entire expression inside there so that the, bang is actually on that entire expression. So this dot main will check main. If it's not an instance of compartment, and then we can say, or, and then we can do this entire thing again, but we'll just change it to be front. And then we can do it again. And do it with side. So if any one of these turns out to be false, then we return true because we're actually asking, is it invalid? So this would prove that it's invalid. So we would return true. But if none of those are a problem, we're going to return false and say, nope, it's actually good. I know that seems backwards, but it's because we're asking if it's invalid, right? Okay, so that should now, check for all of those. And, when this constructor runs, it'll check. And it'll, compare it against what's actually been passed in. It just does it that first time. Let's run it and see, and we're good. So it caught the fact that, I had that wacky object that had nothing to do with the component class, and it threw the error. So that is exactly what we expected to happen. Okay. Next, we want to know what happens when you pass no arguments into the constructor. So we want to be able to just have, be able to say we want, a backpack to just be a new backpack and not have to pass anything in. It can just be completely empty. And we know that the compartment class, let me look at the class here, by default will have an empty array. So we can get empty compartments pretty easily, right? So the trick here is going to be, just making sure that backpack is set up to automatically use those if we don't pass anything in. So let's write the test and then we'll come back and we will modify our constructor. Okay. So I'm going to, again, yeah, I'm going to copy all of this because it's not worth typing out. It's going to be really easy to read. Okay. So we are just creating a new backpack without anything, sending anything into the constructor, which is what we want to test. And then we expect it to be an instance of backpack successfully. We expect main and front and side to be instances of compartment successfully. And then we expect the items arrays to equal empty arrays. And that is really actually just testing to make sure we've set up the way that we're going to do this properly, because the compartment class does already check that this happens, but we want to be sure that we're actually creating empty compartments as part of what we're doing in the constructor for the backpack. So it's worth actually checking all of that. Okay, so now we'll just go do it. I can run it. It fails. Yeah, it throws the error because it's expecting right now to have arguments, and it doesn't have arguments. Okay, so all we have to do then is give these default values. Okay, and the easiest way to do that is what?
It just let them equal new compartments.
Exactly. Yeah, we're just going to instantiate a new compartment and also give it no arguments because we have that set up to default to an empty array. So if we do this correctly here, all of the things we're testing for should pass. This is exactly what we want. New compartment, new compartment, new compartment. And that way by default, boom, you have an empty backpack, which is kind of nice. And it passes. Okay, doing good. All right, so now we're on to our methods. And the add item method, we've already written it, but what we haven't done is think through how to write the test for it. So we're going to do this a little bit at a time. So the first thing I've done, and I did this during class the other day, and you don't have to do this for Mars rover, but I just wanted to model it for you again, because it's a really good practice in the real world. I'm adding another describe block that's nested inside the original describe block so that I can continue the sentence that starts out the backpack class And I can then say add item method to be more specific. And then I can go on to say what I expect. I'm specifying that the add item method can do, not the class can do, because we're not talking about the constructor anymore. We're talking about the method. So this is a great way to keep your from having to say add item method at the front of every single one of these. Just put it in another describe block and group all these together, and it'll read like a full sentence with all three parts. Okay. That's in case you missed me discussing that in lecture. Okay. So does the add item method place items in the correct compartment? Okay. So the first thing we're going to have to do is have some test data, of course. And then we're going to have to call it and see if, and then go check and see if the stuff is there. So instead of manually putting things in like we have been here, where we're like feeding stuff in this way, we're just going to use our new method that we're going to write instead. So let me see if I can speed this up a little bit by getting our initial items set. Okay, here's the initial test data. Get a binder, an eraser, not just any eraser, but a big pink eraser, a water bottle, and a brand new backpack. So far, so good. But now, instead of manually, creating compartments and setting them in, we're going to let our function do the work for us. So we're going to call the function, and I said function, I should say method. We'll call the method on the backpack because that's where it resides, or will reside as soon as we write it. And we'll say we want to add the binder, right? And then we want to do it again. We want to add the eraser, and we want to add the water. Okay. So then after that's done, we expect that we can look in the backpack and we're going to find those items if we've done our job right once we write it. So we'll write the expect statement. We expect backpack.main because we know that the binder is supposed to go in main. We can see that right here. Items to contain, and this is a great use of to contain because we're just looking to see if something is in an array. If it's in an array, to contain works. And we expect it to contain the binder. It's that simple. And so we could say the same thing about the other two. We expect the front pocket to contain the eraser, and we expect the side pocket to contain the water bottle.
Carrie?
Yes.
Should front be in place of main instead of dot items?
Oh. Yes. Thank you. Wow. Yeah. Excellent catch. Thank you. It is very easy, clearly, to start editing this stuff and edit something in the wrong spot, because the deeper you go with these references and these, layered, really deeply nested objects and arrays and things, yeah, it can get really easy to screw this up. But it, with practice and more sleep than I got last night, you'll be fine. Okay, so I think we've got a good test. We'll run it, it'll fail. Yeah, it expected, this empty array to contain item. It doesn't know what to do right now with that because it's just an empty array. So that's the only value it has. So yeah, so we're going to go and write our method and make sure this thing works. And right now, you might remember from when we wrote this over here that we, the first thing we did was take care of, what happens if it doesn't have a location. That's actually not what we're concerned with right now. We're really only concerned with this part where we're going to, go and, take the backpack compartment. In this case, the reference is going to be a little bit different. But we're going to, push the item based on its location into the right thing. And then not worry about that because we're not testing for that yet. Our test doesn't have any items that don't have a location. So, this is one of the ways that you make sure that you're only doing a little bit of code at a time, is to break things up this way. So let's do it. We'll come over here. we will come down here and write our add item that we pass in an item. And we're going to say, now, if I'm going to go into, I'm checking for that compartment, right? So we said that we established before that we know that we can get the correct compartment by just checking the item location, right? Because that string works to help us with the key. But what are we basing it on? We're inside the backpack class. So, we don't want to say this dot main because we don't know if it's going to be main. So we can just, believe it or not, say this and use the bracket notation and say item dot location, just like that. Because this represents the entire backpack and this represents the correct compartment of that backpack. And then of course, because we have set up a compartment class, we actually have to go into that items property. That's the array. And then we can push our item. Did everybody follow that? Does anybody want me to go through it again?
I think I got it at least.
Okay, yeah, that's cool. Yep, just, we're directly tapping into the backpack. We're using the item's location as a key with bracket notation to make sure we get it into the right compartment, main, front, or side. And then we are going into that compartment class-based object and accessing its items array and pushing the item into it. Okay, so that should work because it's that basic, and yes, it does. So then the next step is to modify the method to make sure if the location is null, the item gets put in the main compartment. And we definitely know how to do that. So, but we need to write the test for it. Let's go write the test. Okay. So in this case, I could create, I'm going to create something completely different. We've had lots of notebooks and pens and things. Let's create a dictionary. So we have a dictionary. We give it a name, but we don't give it a location. And we know that our item class constructor automatically sets it to null if we don't give it that parameter, or don't give it any sort of argument for that parameter. So it's null. Now we create the backpack. We've got a new backpack. So now we can actually use the add item method on the backpack, and we can add that dictionary. And we want to make sure that it's going to work properly, but it fails because it can't find items because it doesn't know what the location is. So this is where, and I actually, it fails just because I called the function. I didn't even have the expectation in here yet. Let's put the expectation in. But yeah, it failed because the code broke. But that's part of this, right? We were expecting it to break. So we can just go in and check, that this is important, is that we're actually checking that it's main, because our code, our instructions say, if it's null, make sure you put it in main. That's just default to the biggest compartment. So we absolutely want to make sure that the main array is the one that contains. Wow, okay. Replet's being really sluggish today. If you thought that was lag on your end from the Zoom video, it is not, it's Replet. Okay, so yeah, so and I can run it again, but it's already gonna fail because the code is breaking. So let's go over to here, and we will add that little caveat at the beginning that catches if there is no item dot location. So if that is not there or null or whatever, it's going to set it. Go ahead and set it to main. And now, once it does that, this will work fine because now it goes here and passes in main, and it has an items array that it can push into. So we run it and it passes. Woohoo, all right. We are getting close, guys. We only have 3 more tests. Okay. The last part of the add item method is, does the add item method prevent adding an item to the side pocket if it already has an item? Because, by the way, I don't even know if I covered this, but the side pocket should technically only ever hold 1 item. So we want to write something that prevents it from being added. And so just to double check that the instructions are clear on that. Yeah. All it needs to do is just prevent it from happening. That's the main goal of this. So we can keep this relatively simple. I'll copy and paste to make it go faster. This is all going to look real familiar now because we've been doing these. Okay, so I have created water, a water bottle that goes in the side pocket, and I also have this candy bar, this Toblerone bar, one of those big Toblerone bars, that I'm going to try to cram into this pocket, but it won't fit because there's already a water bottle in there. So we create a new backpack. We use the add item, which is the thing we're testing. We are still inside this describe block here that specifies that it's the add item method of the class. And we are adding the water, and then we're attempting to add the candy bar. And we're not throwing an error, we're just going to prevent it from going into the array. So then we go and we check and we say, I expect that if I look in the side compartment and the items array of the side compartment of the backpack, that it's going to contain water, but it's not going to contain candy bar. And so we can verify that it still has what it's supposed to have and doesn't have what it's not supposed to have. And that is a good way to kind of check it both ways, right? So I run this, it fails because it actually is finding both in there because it is just, adding it in willy-nilly. It's, like Doctor Who with dimensional engineering. It's bigger on the inside. It doesn't really work in real life though. So we're going to have to fix this. All right, let's go over here and modify this, make sure if it already has an item, the item's not added. And so we can just do another one of these like early return situations. Well, this isn't an early return. This is just setting a property. This one is going to be an early return situation. So we'll check it and say, like, if the location is side, because that's important. And if this dot side dot items, the array that's in the side compartment, if the length of that array is greater than 0, then we just want to return without doing anything. And you could actually argue, that you could put this one even first. It doesn't really matter which order they're mutually exclusive, so it doesn't really matter. But so if the location is side and if the side items array has a length greater than 0, then it means something's already in there. And so we need to just return and not do anything. We just leave the old item in there, don't put the new item in. So this line of code never executes because we returned early. So now I'll run it and it passes. Okay, so that's it for that array. I'm sorry, for that function method. One last method to write here. Fill. So we want to write a method called fill that'll take in an array of item class objects and add them all to the backpack. And so, if we have an array and lots of objects, we can iterate through it and, add the items on each iteration. So that's a real straightforward problem to solve, but let's write the test for it first. So the first test, and you'll notice here, I've ended the describe block that was specifically for the add items test. And now I've started a new one that's for the fill backpack method. And actually that shouldn't say fill backpack, it should say fill. the fill method. And these tests are going to be concerned specifically with this method. So now we have a couple of specifications inside this nested describe block. So does it successfully add all of the items that have been passed in? So it should add every item to the backpack if given an array of items. Okay, so try to be mindful of the time here. So I'm going to do some copying and pasting. All right, so let backpack equal new backpack, create some items, textbook, pen, water. And then I put those in an array and I feed them to my fill method that I haven't written yet. And then I would expect that every single one of them is contained inside its respective compartment. This one's supposed to go into main, so I expect it to be in main. This one's supposed to go into front, so I expect it to be in front, and so on and so forth, right? But we didn't have to do like we did up here, where we call add item 3 times. Now instead, we're just giving it an array. And maybe this would be like 12 items, right? And so we didn't have to have 12 lines of code, we just have to have an array. So this will work. Once we write the code, it will work. It's going to fail right now. Yeah. Okay, so let's write the code. All right, so here's where, the first part's pretty straightforward. We're just going to write a for loop to loop through that array. Be pretty classic. I is less than items.length. And increment by 1. Okay. And we just, wow, okay. Shared changes. Yep. Okay. We're just going to call this dot add item. You have to use that key, this keyword, of course, because we're referring to something from inside the class. And then we just give it items at index I. So whichever item we're currently on as we're looping through, we add it in. And it should be that simple. So let's run it. And it is. So we already wrote something that would take care of any possible situations with an individual item. So all we had to do was loop through and call that over and over again for each one. Okay, so that part's easy, but then the next step says the method should return an object with 2 properties. So we actually need to not only do something, we actually need to have a return value now. It should return an object with 2 properties: confirmation, which is like a message that indicates success that we can write, and also a property called items added that represents the array of items that were added. And yeah, so let's write the test first. I will borrow from here to speed it up just a little bit. Okay, so we create a new backpack. It's actually the same, it's the same items from here actually. So, but the difference is, look at line 107 compared to line 94. So in line 94, all we were testing is that it did what we needed it to do, right? Now we're testing that there's some sort of response coming back. So we actually need to have a variable to store the return value from calling the fill method. I cannot stress enough the distinction between these two things and how important it is for you to understand this when you work on Mars River. So I want to make sure to give you an example that will help you. So in this case, we are going to have some sort of return value once we modify our fill method, and we're going to store it in this response. And then what we're actually testing is not the backpack. It's not the items in the backpack, and it's it's just testing what's in that response object. This is a big deal. This is something that everyone gets hung up on Mars rover. So this is a very big distinction from any of the tests that we've written before now, this last one. So we're going to actually check the response properties. And remember that in the instructions, it said we needed to have two properties, right? Confirmation and items added. One's a message, one's the array of items. So we're going to come back over here to the test and we're going to check for both of those. So I'm going to say, I expect the response and its confirmation property specifically to equal, and then I need to decide what I want that to say. And I'm going to keep it really simple. Items successfully added. Because it's really just a confirmation message. And then we'll check the other property, response.items added. Oh boy. Okay, and here's a good example of where to equal is necessary instead of to be, because we're actually comparing arrays. So I want to make sure that the items added is actually the original items. So I run this, it fails because it can't read confirmation of undefined, because there is no return value right now. Response doesn't mean anything yet, but it's about to, because we're going to create it. So now we come over here and we say, all right, I've got this method, Phil. It does something for me, but now I actually need to return something. So I need, and it needs to be an object, and I need to build that object. So we're going to, build the response object first. And we can just, make it a regular object, right? And we'll set the properties in it, confirmation, and item successfully added. And then comma, items added. And that should just be items. It should just be what was passed in the first place. That's all we really want to do, is just kind of, regurgitate that back. So that's the response object. And then we just return it. And if that response object is what's sent back, then we can, very easily just mirror the name of that and call it response on the other end, because it, it correlates, right? And just check those two properties for these values. So, and we already wrote the test to do that. So if I run it now, it passes. And by the way, when you're doing this, like, let's say you have something much more complex than this that you're building. Let's just say, maybe you will have something way more complex that you're building, and you're getting stuck and it's not turning out quite right, and you're not sure like where you went horribly wrong. You can always, I know that it seems a little weird because you're running Jasmine out of the index file. And so what you're seeing here is the tests, right? But you can log things to the console. So if you haven't already done this, so let's say I set that response object, it didn't come out quite right. I can't figure out why, and I'm frustrated. Well, just log the object, right? So I might come in here and I might even put in a little message for myself to make sure I can pick it out, debug, debugging response or something, and put a comma in there, and then, the response object, and then I run it. And now I can see that, after it ran through some of those tests, when it ran this one, it logged it for me, and then it kept going and ran the rest of the tests. So it's in here, and I can actually see the structure of it. I can see, okay, I've got confirmation and it has that string. And then the next property is items added, and it's the array of the item class objects that have the properties name and location. This is really important. So I would recommend that you have some things like this in your code, where you're just logging things for the sake of being able to constantly check on them and make sure they are what you think they are. Because otherwise you're going to get real frustrated and you might think that your tests are written wrong, and maybe they are, and that's okay. You gotta work both ends against the middle sometimes when you're first learning how to write the tests. But you're not going to know unless you're looking at this. And I want to point out, I will go find this for you. Hold please. Okay, let's go to the instructions, because one of the things that they've improved this vastly since my cohort was the guinea pig. They actually, here it is. They're on different pages. Oh, okay. So they've put it on different pages is what they did. This is what I wanted to show you. Okay, so if you're on this rover part 3 page, this is the object that you are building. And so this is an example of what the object looks like. And it can look different depending on what commands you send. But this is the object output that you would expect to see that's coming back from the rover if you give it these commands with this message and this position. Okay. So by console logging the object that you're building, it kind of like I did a few minutes ago, you're going to be able to compare and see, am I setting this up right? Like, do I have the right properties in the right places? Do I have, arrays in the right places and the correct object in the array? But if you're doing it, bit by bit, and this is the big picture, right? This is the rover. This is kind of synonymous with backpack, right? It's you're working on all the little parts first. And then when you get to the rover, it's when you're putting it all together. So don't fuss over this in the beginning. Actually, go back and do, everything step by step. And then by the time you get there, you should be in pretty good shape. All right. Does anybody have questions?
No, not here.
Okay, that's cool.
While we're on the assignment 3, could you potentially explain test 2 for me, please?
Test 2. Okay.
Command test right there. I feel like I wasn't understanding it yesterday when I was looking at it, and after today, I feel like I'll understand it better. But maybe having somebody explain it to me would be the breakthrough that I need.
Yeah. So it's command type. So this sentence is what you need to pay attention to. It says the test checks that the constructor in the command class correctly sets the command type property. So relating that to what we were working on today, I had a number of tests where the only purpose of the test was to make sure a property was set to the value you expected it to set through the constructor when you instantiate an object from the class, right? So that's really all it's doing. They tell you what the property name is, and they tell you that you're going to set up the constructor so that it will give you a value that you can then attach as the value of that property in your constructor. So that's it.
Okay, thank you.
Yep. Yeah, I know this is definitely an overwhelming assignment. There's so much to think about, but sometimes you just have to come back and reread it and just really pay close attention to the exact language they're using. A lot of coding is about terminology. And you guys are so new, like most of you are probably new enough at this that a lot of it's very unfamiliar. You're learning a lot of new words and references for things. And here's the other thing. I'm going to tell you something else. All the different instructors that I have seen over the last few years, and not just at Launch Code, but like Udemy courses I've taken or whatever, and all the people I've worked with, people have different terms for different things. And so you'll hear one person refer to something a certain way, and then you'll find out like months later that, oh my gosh, that means the same thing as this other thing. And I just didn't even realize that they were the same concept this whole time. So, that's going to be happening a lot for you guys for a little while. But if you are, trying to learn anything you're exposed to, and you can certainly go research things too and try to get a better handle on it if you're not sure what a term means. But understanding the difference between a property and a parameter, for example. I was trying to use that language a lot as we were going through this to make sure that it was clear kind of, what belongs to what. But when you read these instructions, they're making the assumption that the difference between all of these different things, and that it's, you're tracking with it as you're reading it, exactly what they're talking about. But it's really new for you guys. This is all brand new. I just taught classes 2 days ago, right? So it's okay if you're reading this and you're going, I have no idea what that means, So just reread it a few times, go back and revisit, the original concepts, the lecture slides, whatever, that'll help you make sense of, parameters and properties and constructors and methods and, keywords and all these little things, because it can get real jumbled up real fast. But the more comfortable you get with all of that, the easier it becomes to read these kinds of things, and the more it'll click. It just takes time and practice and the pursuit of knowledge, active pursuit of knowledge. Any other questions? Okay. Well, with that, I thank you for coming and giving me a live studio audience. I'm going to get the code, starter code and solution code available, and I'll process the video and get it uploaded and